the class. Let your friends coming and joining. Tell them in the group class started, huh? We are
Okay, sir.
left we are left only with this one, huh? Mohsena Saleha Azmi. Dr. Mohsena Rahman, who is that?
Sir, that is Shirazi. Shirazi.
Okay, Shirazi, okay. Please tell Shirazi to make his name.
Okay, sir.
Hmm.
Shirazi, change your name.
It's very important. Sadika is coming. Sadika, Saleha. Yeah, now 7 participants. Yeah, we we are left with this, huh? This part only. Other things we discussed before, huh? Till here we are done in last class. Also, we discussed Jasmine Alam. Who is Jasmine Alam?
Sir, Iftekhar.
So why they are not changing the name? How can I understand it is our student or not? Yeah, Iftekhar, you change the name. It's written Jasmine Alam. And um, Shiraji, you change the name. It's written Dr. Mohsena Rahman. Shiraji, change the name. Hmm. Okay, now look, we also discussed this part last class, right? Scientists, how they are using or writing the SI units after the name of scientist. Okay, Newton, joules, ampere, watt. We can make it short form. That is capital. This part is done also in last class. Only this much is left. The metric system. Though we discuss a little bit about metric system in last class, now we are going through it again. Okay, now uh, Rohan. Rohan, you please read from here
Yes, sir.
the metric system, huh? And also read this, huh? This part also you read. Old
Mat-
imperial, new metric. This way you read, huh? All these things. Okay, continue.
the matrix system on imperial 12 inches equal to 1 foot, 3 feet equal to 1 year, 22 years equal to 1 G, 10 G's equal to 1 furlong,
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 furlong. One
furlong,
furlong. Hmm.
8 furlongs equal to 1 mile. New metric 10 millimeters equal to 1 centimeter, 10 centimeter equal to 1 meter, 1000 meters equal to 1 kilometer.
Okay, from here we are familiar with this. This all we are familiar with. We already discussed these things many times, right? We are using this one nowadays, and also in our country we are using this. Uh, this part is also we are using in our country. If you see if you have any ruler with you, then if it is 15 centimeter or it is 30 centimeter, both you will get inches, right? Inches along with the centimeter, we have inches. Do you understand what I'm saying? Hello.
Yes,
Okay. So these two are familiar with us, and the other things we don't see nowadays. Mile, sometimes we also get it in our country. We say mile. That uh, mile is very close to kilometer. A little bit more than kilometer, huh? That is mile. We have the relation how many kilometers are 1 mile. Okay, now continue this much.
Many scientists now use unit based on the metric system. This was introduced by French scientists in the 1790s after the French Revolution. It sorted out the molded system of units used before the basing everything on the number 10. The meter unit of length was defined as 140 million of the Earth's circumference. The standard meter was a bar with two marks on it kept in Paris. The gram-based unit of mass was defined as the mass of the cubic meter of water.
Okay, so here you got two very important things. That is the way we are getting now meter, that is 100 centimeter, is the 40 millionth of Earth's circumference. And this is how can you measure the circumference and how will go for measuring the
Sir, 2 pi r,
circumference.
pi
But
r or pi
now,
t.
now, now we have one, standard in kept in Paris. It is a bar. Okay, it is a bar with two marks on it, and that length, that is equal to 100 centimeter, is taken as the standard of meter. Okay, and also you are getting another information, that is mass of 1 gram. 1 gram mass, and that is 1 cubic centimeter of water. That means if you are taking 1 cubic centimeter of water, that's giving us 1 gram. So these are the standards. We can remember this one, especially the mass one. You will remember. Okay. Then we are continuing the other parts. Here, very important thing. Can you continue this part? Using the right units is important.
Using the right units is important. A very expensive space crashed on Mars because the controllers had created it landing data in meters while its computer was programmed for measurements in feet.
Okay, so it's important that when we are using anything, unit, any unit we are using, like here they gave about the unit of length. Also, we are using the unit of mass, right? We should be careful. Are we using gram or kg? We should be careful. Are we using feet or meter or centimeter or millimeter? Otherwise, our calculation will be wrong. In your level, uh, we are doing the calculations, numerical questions, right?
Yes.
And one day you will be the also scientist. You will work in the NASA, or you will work in any scientific lab, microbiology lab, or many other places you might work. So in that cases, you should be very careful about the units. You should be very careful about the given data, provided data, and the collected data. Okay, that one is our target, that we should be careful during using the units. Okay, you understand?
Yes, sir.
Okay, now from other students, we can go with other students like Iftikhar. Iftikhar, hello Iftikhar.
Hello, sir.
Yes, can you please continue this part, setting new standards?
Which part?
Yeah, this part we are showing on the screen, right side, you see, setting new standards. You can see the screen, Iftikhar.
Sir, আমি পড়ি স্যার।
Who? Wasif?
Sir, Wasif.
Yes, continue, yeah.
Setting new standards. The original definitions of the metric system are not accurate enough for modern scientific work. For example, a standard meter bar will expand and contract slightly if its temperature varies. So it isn't really standard at all. That is why scientists have had to come up with new and better ways of defining units. Here, for example, this is the modern definition of the meter.
Okay, so in our previous example, we got the length unit meter. It is preserved, a bar is preserved in Paris, that is taken as the standard. Now, as we are growing, the scientific research is going, and we understood that in this way, if we are using that one as a standard, that one sometimes does not give us accurate reading, because the metal bar that can be expanding or contracting with the temperatures, right? So if we are taking that length as the standard, that might be bringing some errors, right? Isn't it? Hello, do you
Yes, sir.
understand what I'm saying? So
Yes,
to
sir.
Yes, sir.
avoid those errors, so to avoid those limitations, we now use another one, that is meter is the distance that one is traveled by light in a vacuum in a time of 1 by, actually this one is a big number, right? So this one is, if we do it in standard form, it comes 1 by 3 into 10 to the power 8. Okay, if you write in standard form, that one we can say easily 1 by 3 into 10 to the power 8. That is standard form or index form. 3, if you take 2.99, 10 to the, do you understand this one, what I am saying? 10 to the power 8. If you have this idea, do you have the idea of index form or indices standard form? Like you have 500, you can write this one as 5 into 10 square. 5 into 100 you can write first. Can you write this? 5 into 100. Hello? Hello? Can you write this way,
Yes,
5
sir.
into 100? Then you can write 5 into 10 square.
Oh,
This one you can write 10 square. This is called standard form or index form. Okay, 5 into 10 square. That one is showing 10 square means 100. Okay. Similarly, this one you can write as 2.99. 2.99. You see, after, if you are taking here decimal 2.99, then how many digits are coming? 1, 2, 3, 4, 5, 6, 7, 8, right? So we are
yes, sir.
writing here 10 to the power 8. Is it clear now?
Yes, sir.
So 2.99, if you take only one digit, approximately it is 3, right?
Yes, sir.
So
Yes, sir.
it's coming 1 by 2.99 into 10 to the power 8. That one I wrote 3 into 10 to the power 8. That's making your presentation and your sayings or your describing more easier, right? So this length,
Yes, sir.
yeah. So this length, the length traveled by light in this time, these seconds, that is called the unit of length meter. So this one is the standard because speed of light is constant in vacuum, and if there is any change, a little bit change, even that is not, is creating any big change in our unit because it's a big ratio, right? Isn't it?
Yes, sir.
That's why we are taking this one as the standard. We will get some other proofs, like uh, you already know what is meter. That one is coming from second, but what is the standard of second? How can we define second? That one is coming now. Can you please continue this one? Of course.
Of course, to define the meter like this, you have to have an exact definition of the second. That is rather complicated, but it is based on the rate of a particular vibration which can occur in certain type of
Cesium atom.
cesium atom.
Cesium atom. This is one of the elements in our periodic table. That is cesium. Cesium atoms or all the atoms, they have their molecules inside, right? Uh,
Yes,
all the molecules, all the atoms, they have electrons, protons, neutrons, right? Uh,
yes, sir.
and if you are taking one sample of cesium atoms, then we have vibrations, right? inside the
Yes, sir.
inside all these elements there are subatomic particles, they have some vibrations. So
Vibration.
this vibration rate, rate of vibration, we can consider with the vibration of pendulum. Okay, this way they are having periods. If one pendulum is going to right side and another one is going left side, right? Once it is going right
Yes,
side,
sir.
another one is left side, so this way it has oscillations. Once it is going right, then going to left, again returning to right side, that one is called, it's one period, complete cycle,
Okay.
eh? This is called one complete cycle. So similar way, all these atoms, in their molecular level, they have vibrations and they have period of vibration. Okay, and that one is almost fixed, constant, that how many vibrations they will give in a fraction of second or microsecond or millisecond. This is fixed, and that one is called atomic clock. Uh, Based on the base of this idea, this concept, scientists, they made one clock that is called atomic clock, cesium atomic clock. And this clock is very accurate. In 3 million years, uh,
300,000, sir.
uh, so 300,000, yes, 300,000. So it's 3 lakh, right?
Yes, sir.
Yeah. So in 3 lakh years, it's even not giving a change in 1 second. 1 second is very small, right?
Yes, sir.
1 second is very small time. So even in 3 lakh years, it will not give a change in the second, 1 second. So how accurate it is? All of you are getting it? Hello,
Yes, sir.
scientist, young scientist,
No,
all
sir.
the young scientists. Are you getting my discussion? Are you
Yes,
understanding?
sir.
No, I didn't understand this part.
Okay, this last part or before that also?
Last.
Okay, last part. Okay, I am not done. That's why you did not understand. When I will be done, then you'll understand, hopefully. Look, this one is a diagram, the person is standing over there is the diagram of cesium atomic clock, and this clock is so accurate that due to the vibrations of the you know uh, particles inside the atom, uh, those are giving the period of vibrations. We are getting the reading, and this reading is not changing. It's so accurate, so same that it's not giving any change even 3 lakh years. Like what happens in our life, we see that whatever the instrument we are making, whatever the the scientific device we are using, there are some errors, there are some limitations, right? Isn't
Yes,
it?
sir.
And those are giving us fluctuating readings. Even in our house also, if you think that the clock we are using, if the battery is not working properly, sometimes the second head is not moving, right? And we are getting the clock slower, isn't it?
Yes, sir.
But the atomic clock is not becoming slower. It's going automatically. It's running automatically, and even in 3 lakh years, not even 3 lakh days, not even 3 lakh months. It's going for 3 lakh years, not giving a error of 1 second. So how much accurate it is?
Yes, sir.
So this one is used as a standard for setting all other clocks. That means that one is taken as the standard, and all the clocks around the globe, they are following that one. Is it clear now, Saleha?
Yes, sir.
Yes, sir.
Hello,
Yes,
Saleha.
sir.
Now it's clear, right? So thank you so much. And we actually are not going for more deeper ideas how this clock is working. Just we are trying to understand. Yes, now how the science and technology developed, and slowly we came to here. In our last class, we understood how the previous people, our previous generations, they used to have the unit of lengths, right? They used to have the unit of lengths, the feet, how they got the hand, uh, how they got. So after this, they took the length of the bar. Even after taking the length of the bar, they are not satisfied. We need more accuracy, and for that accuracy, we are now using the speed of light to define length, right? Isn't it? Hello.
Yes,
Yes,
sir.
sir.
So, to give you that idea that science is growing gradually, the history of science, the history of measurements, history of units, how this is developing day by day, we brought all these ideas. That's our main target, so that you have also, have some, interest to grow, to discover, to invent. Okay, more things, whatever available with you, you can move forward, you can think more widely. We brought all these ideas. That's our target. Is it clear, everyone?
Yes, sir.
Okay, now we have here the questions on chapter 1. If you have seen my posting in the Google Classroom and in your group, I mentioned what we are going to discuss, right? Okay, did you see that one? Hello?
Yes, sir.
When we are
Yes, sir.
posting the class Zoom meeting ID and password, that time I also mentioned the uh, topic, right? What we are going to do in the class. Did you check that one? Look,
Um,
continue section 1. Can you see this? Yeah,
Continuous.
I,
Yes, sir. Yes,
yeah,
sir.
I always mention this. So you whenever you are getting the link of class, that time you get prepared mentally and get prepared also physically, that you should have the papers and pencil with you, because we are now going to solve questions on chapter 1. Okay.
Okay.
Okay, you be prepared with your pencil and your paper. Okay, you have to write
Okay, sir.
something. You have to copy here something. This is page 16 on your book. Huh? These question answers are on page 16, you see. And we will try as much as possible today. And almost everything is done from this chapter. Only these questions are left, and similar questions already we did, right? Already we had discussions like in question 2 we have something, and question 1 we have something. You are familiar with this type of questions, right? Already
Yes,
we
sir.
did in different sections. So these are not new at all. You already have the idea, just we are going for revision of those similar questions. Uh, However, you should copy them. In your copy,
Okay,
you
sir.
should preserve them. All of you are ready for writing.
Yes, sir.
Rohan, then Hassan, Azmain, Ruhi, Tahmid Shiraji, Saleha. All of you are ready. Sadika, Iftikhar,
Sir.
Ruhan. All of you are
Yes,
ready with your paper and pencil.
Yes.
Okay,
yes, sir.
please, you be ready, and please take part in the discussion. I want everyone's participation. You don't be silent. When you are asked any question, anyone, you be ready and you answer then and there. Don't take long time. Like Iftikhar, I asked him to read, even he couldn't do it quickly. Get ready, everyone. Questions on chapter 1. Question number 1 we are going to read. Then Sadika will help us to continue this. Sadika,
Yes, sir.
please continue this.
Sir, number 1.
Yeah. Copy and complete that one. Yeah.
Copy
Read
and
everything.
complete the table shown below.
Mhm.
Measurement, length, unit L, unit meter,
Mhm.
and symbol M.
M you should
I
mention
mean
it,
L,
because there
L,
is,
L.
yeah, you should mention it is small m or capital M. Uh, because
Small M.
some of the units we should use capital. Okay, because those are after the name of scientist. You should be very much careful about them. Uh, at least in this level, if you are not careful, then in your next years you will also do mistakes. So from now on, you be familiar with them. Now continue, mass continue, please.
Mass, unit kilogram, symbol kg, small letter.
Yes, very good, very good. Then this is one is tricky. They gave you the symbol, right? The third one.
Sir, measurement, time, unit, seconds.
Symbol is S, small s. Okay,
Yes.
very good. Then continue. Next, fourth one.
Measurement, measurement, current, unit ampere, and symbol A, capital
Capital A.
letters.
Yes, this one is capital letter because it's the name of scientist. Clear? Yeah, then
Yes, sir.
continue. Continue.
Temperature, unit, um,
Kelvin.
yes, sir.
Temperature unit is Kelvin. 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 You never heard this, Kelvin? We have degree Celsius also, but our SI unit is Kelvin. That one we'll use. Is it clear, Sadika?
Yes, sir.
So Kelvin. It is also after the name of scientist. So symbol will be capital K. Okay, continue then.
Symbol T.
Which one?
Sir, temperature.
No. I said Kelvin.
K.
K.
Uh, K. Capital K. Should I write or you understand? This one?
Sir,
Look,
can you write
Sir,
it?
yeah. Look, this one, when we are writing in full form, it is small k. Kelvin. Lord Kelvin. His name is Lord Kelvin and he is a scientist. That's why the short form will be capital K. It is SI unit. Is it clear? Yeah. Sadika, is it clear?
Yes, sir.
Then area, continue area. Yeah. Area. Area, what is the SI unit of area?
Sir, square meter.
Very good, very good. Square meter. Then here you will write m square, right? Small m square.
Yes, sir.
This way. Yeah, then continue.
The unit for area
Next one, after area, what's that?
meter
Hmm?
cube.
This one, meter cube, right?
The volume.
Yes, very
Volume.
good. Yes, volume. Volume. So volume is
Next one, force. And
cubic
capital
meter,
M.
right? Cubic meter,
Yes.
right? Volume. In unit, what you will say? Cubic meter. You should write here cubic meter. Cubic meter. Yeah, cubic meter.
Yes.
Yeah,
Next one,
Wasif.
force.
Wasif. Hello,
Capital
Wasif.
F.
Wasif, are you there? Wasif, are you there? Hello, Wasif. Wasif is not there, right? Now, look, the last one is force. Already you told me it is force, right? Force, then Newton,
And
and
capital F. Capital F.
this one should be
Capital
capital
F.
N. Very good.
Capital N.
So this way, look, all these things you helped me. Those you know already, right?
Yes.
Just I had to recall some of the things to make you more confident, right? To make you more
Sir.
confident. This way you can also solve 2, right? Question 2. Can you do question 2 by yourself? Can I give you this one as homework?
Yes, sir.
Okay, so this one you do as homework, question 2, and question 3. Look, what is written there? Question 3. We are going down. Similar way you can do, right? 300 centimeter in meter. Can you do it? 300
3
centimeter.
meter.
Very good. So you are much more smarter than 500 gram in kg.
9.
2.5.
0.5, huh?
Sorry, 0.5.
0.5 kg. So you do the working, then you tell me. Huh? This way, if I ask you F, 0.75 kilometer, you can do, right? 0.75 kilometer. How can
75 meter.
no, 1 kilometer is one. Is it 75 coming? Did you multiply with 1000?
715.
Yes. So this way you should multiply. Yeah. If you get one thing like 1 kilometer and then you have to convert to meter, then you first get the relationship. Yeah. How many meters are making 1 kilometer? So that one you are getting 1000 meter is 1 kilometer. Then you multiply it 1000. Is it clear how to do? Hello, is it
Yes,
clear?
sir. Yes.
Yes, is it clear? So if it is clear, you can do G also, right? You already know how many grams are making 1 kg. So 2.5 kg, how many grams you can calculate it. Also you can find it. So 2, 3, these two are homework, okay, for you. Is it fine?
Okay, sir.
Or you will take more, the whole page?
No, no,
No,
no, sir.
sir.
Okay, fine. Only 2 and 3 is your homework. Is it okay? 2 and 3 is your homework. 1 we did, and we also discussed some of the questions from 3. So I think you can be able to do. Is it okay, everyone?
Okay, sir.
Okay. So you have any questions, any more questions from today's class? Or you have any queries? We are done with this chapter. We are planning to have a test on this next week. Most probably Sunday, if you agree. Okay. Just have a plan and share your ideas next class. Thank you so much. Okay. Allah Hafiz, everyone.
Allah, Allah Hafiz, sir.
Sir.